Welcome to my first lesson on inferential testing, a key part of research methods for AQA psychology. When I first started teaching this topic, I'd long forgotten what I'd learned about it at university, so I was dreading it a bit, thinking this was going to be really complicated and difficult. As I immersed myself in it and prepared my resources, I found myself really liking it. Overall, I think research methods, including inferential statistics, is in some ways an easier part of the curriculum. It just requires careful logical thinking and much less memorization than is required for approaches in studies. So, I've put together the content in a way that builds gradually to help you make sense of it all. We begin with looking at the difference between experiments and correlations, experimental designs, and levels of measurement in today's lesson. Knowledge you'll need to understand why certain statistical tests are chosen in different studies. Let's start by distinguishing descriptive and inferential statistics. Descriptive statistics, as the name suggests, describe data. So the mean, median, mode, range, standard deviation summarize data to show trends. Inferential statistics go a step further. They test whether the difference or relationship we found is statistically significant. So, as the name suggests, what we can infer from the results. Choosing the right statistical test depends on three key factors, so you have to make three decisions. Difference. Are you looking for difference between conditions or a correlation between variables? Design. If it's a difference, what's the experimental design? Independent groups, repeated measures, or matched pairs, or in other words, unrelated or related. And data. What is the level of measurement? Nominal, ordinal, or interval. So we'll go through each of these now, step by step, because your ability to choose the right test depends on these. On the exam paper, you'll be given a scenario and you have to decide whether the study looks at a difference or relationship. Often, you can determine this based on the phrasing of the hypothesis. People who watch football weekly remember more scores than those who don't. That's a difference. The more alcohol consumed, the more days absent from work. That's a correlation. If the study is an experiment looking for difference, you next consider the experimental design. There are three main designs. Independent groups, where different participants are found in each condition. Repeated measures, where the same participants do all the conditions. And matched pairs, where participants are paired on important variables but still tested separately. In terms of inferential testing, repeated measures and matched pairs are treated as related designs, while independent groups are unrelated designs. The third thing you have to figure out is what type of data you're dealing with. Nominal data, categories, ordinal data, ordered ranks, or interval data, which are numerical scales with equal intervals. Let's take a closer look at each one of them. Nominal data is categorical. It places participants into groups or categories. For example, counting how many people have cats versus dogs. Recording favorite ice cream flavors. Each participant can belong to only one category, and we usually use the mode to describe nominal data. This kind of data is very simple, useful, but not very informative or sensitive. Ordinal data is ordered or ranked, such as ratings or Likert scales. For example, asking participants to rate how much they enjoy psychology on a scale from 1 to 10. The intervals between numbers aren't equal. A rating of 8 isn't necessarily twice 4. That's why we call it unsafe or subjective data. It's based on personal opinions, not precise measurement. In analysis, ordinal data is usually converted into ranks to make calculations easier. Interval data is more precise. It's measured on public standardized scales, like temperature, time, or weight, where the intervals between numbers are equal. For example, 20 degrees is exactly 10 degrees warmer than 10 degrees, because temperature is measured on a fixed scale. This makes interval data the most informative and reliable type because it allows us to use more powerful parametric tests. Right, Time for you to see if you can determine the types of data for these examples. Pay special attention to how scales are used. Bear in mind that self-report scales might sound interval, but they're ordinal unless each point represents a precisely defined unit. So, here are the answers. Time taken to recall a list of words after hearing them. That's interval data. Time is an objective, continuous measure. Participants' choice of revision strategy. That's nominal data. It's categorical. Participants fall into one group or another, like flashcards, mind maps, practice questions. Students rating how anxious they feel before an exam on a scale of 1 to 10. That's ordinal data. It's ranked. The numbers have order, but not equal intervals. It's subjective. Judges scoring contestants for creativity. That is again ordinal data. Even though numerical scores are used, these are subjective judgments. Participants' heart rate. That's interval data, measured using physiological instruments, objective and equal units. And patients classified by diagnosis type. That's nominal data, simple categories. Ranking students by exam performance. That's ordinal data. This shows an order, first, second, third, but we don't know the size of the gap between ranks. Time taken to solve a logic puzzle. That's interval data. Again, time. Playground study, prosocial versus aggressive behavior. That's nominal data. These are discrete categories. Happiness ratings on a 5-point Likert scale. That's ordinal data. Ordered data from very happy to very unhappy, but not equal intervals, subjective data. Medical files categorized as inpatient, outpatient, or discharged. That's nominal data. We've got categories again. Survey on gambling attitudes, strongly agree, strongly disagree. Ordinal data. So we've got a Likert type data, ordered but subjective, so not truly interval. And reaction times in a Stroop test. If you haven't tried that yet, you should, it's fun. That's interval data measured in milliseconds, so precise, objective, and continuous data, time. Pause here again for a few minutes so you can have a look at the exercise and complete it yourself before I tell you the answers. The answers are as follows. So in column A, placings, we've got ordinal data. These are ranks. We know the order of performance, but not the exact difference between each person's memory ability. In column B, time taken, we've got interval data, so time is measured using equal objective units, seconds. And then in column C, we've got nominal data. These are categories. Question B, which measurement is the most sensitive or informative? The answer would be interval data, so column B. It gives the most precise information about performance because it includes equal intervals and allows more mathematical operations to be carried out. And then for question C, the students claim that Patel must have a better memory. This is a great reminder of why levels of measurement matter. The ranking, ordinal data, tells us Patel was first, but not by how much. Without the interval data, the times, we can't tell whether Patel was only 0.2 seconds faster or 20 seconds faster. So ordinal data alone can be misleading. And this brings us to the end of this hopefully fairly straightforward first lesson, equipping us with the knowledge that we need in order to choose the right statistical test in the next lesson. Thanks for watching. See you soon.